Welcome to the section Introduction to Pandas. Pandas is an open source Python library mainly used for data manipulation and data analysis. It provides powerful data structures that help us to handle structured data easily. Structured data means data arranged in a proper format like rows and columns, similar to an Excel sheet or database table. Pandas is widely used by data scientists, analysts, and engineers because it makes data cleaning, processing, and analysis easier. Pandas provide two important data structures, series and data frame. A series is a one-dimensional labeled array. It is similar to single column in an Excel sheet. A data frame is a two-dimensional table containing rows and columns. It is similar to an Excel spreadsheet or SQL table. For example, student details such as name, roll number, and marks can be stored using a data frame. Pandas help us to perform different data manipulation operations. Cleaning. It allows to clean data, filter required informations, and transform data into a suitable format. How to handle missing values. Can also handle missing values represented as none. For example, if a customer datasets contain missing phone number, Pandas can identify and handle those missing values. Pandas also support merging and joining multiple datasets. To use Pandas, first we need to install the library. We can install Pandas using the command pip install pandas. After installation, we can import pandas into our Python programming using command import pandas as pd. This alias pd is commonly used to access pandas function easily. The key features of Pandas. Pandas provides indexing and selection technique to access specific data. We can select rows and columns based on labels or position. The LOC function is used for label-based selection and ILOC function is used for position-based selection. For example, from a student data frame, we can select only the mark column or a specific student record. Pandas supports aggregation operations like sum, average, and count. The group by function is used to group similar data together. For example, in a company dataset, employees can be grouped department wise and we can calculate the average salary of each department. How to handle the time series data. Pandas provides special features for handling time series data. Time series data means data collected over a period of time. Example includes stock price, weather information, and daily sales record. Using Pandas, we can analyze trends and patterns over time. Pandas work well with other Python libraries like NumPy, Matplotlib, and scikit-learn. It can also read and write data from different formats such as CSV, Excel, JSON, and SQL database. For example, a company can import sales data from an Excel file, analyze it using Pandas, and export the final report. You can see the examples with pandas. In this example, we create a simple panda data frames. So the first step is import pandas. Then we create a data in form of rows and columns. So the data frame stores this information like a table. When we print the data frame, the output displays the data in a structured tabular format as shown here with name, age, and salary. Pandas function. In this slide, we will see how to create a data frame and how to import data using pandas. A data frame is one of the most important data structures in pandas. It stores data in the form of rows and columns similar to an Excel spreadsheet or a database table. For example, student details such as name, age, department, and marks can be represented as a data frame. So we can create a data frame from different types of data source such as list, dictionary, or existing files. While creating a data frame, the data is organized into rows and columns which make it easier to analyze. Data frame function. The data frame function is to convert a data into a tabular structure. It arranges the given data in a proper format with rows and columns. Importing the data in real-world application, the data is usually not created manually. Most data is stored in external files such as CSV files, Excel files, JSON files, or databases. So pandas provide different functions to import these files directly into Python. How to read the CSV data? The read CSV function is to import data from CSV file. CSV is nothing but common separated values, the most commonly used format for storing tabular data. For reading Excel files, the read Excel function is used to import data from Excel files. Many organizations use Excel to maintain reports and records. Using pandas, this Excel data can be converted into a data frame and analyzed easily. Reading JSON data, the read JSON function is used to load JSON format data. It is commonly used for transferring data between application and web services. For example, the data received from web application or an API can be imported and analyzed using pandas. And the last function read underscore SQL function is used to import data from an SQL database into a pandas data frame. In real-time application, the large amount of data are stored in databases such as MySQL, PostgreSQL, or Oracle. Instead of manually downloading the data, pandas can directly fetch from the record information from the database using an SQL query. The SQL query specifies what data we need and the connection parameter provides the link between Python and the database. After retrieving the data, pandas convert the result into a data frame format, making it easier to analyze. The real-time example for this is a bank stores customer transaction details in a database. Using read underscore SQL function, we can fetch only the record transaction records, convert them into data frame, and analyze customer spending patterns or detect fraud activities. Pandas functions, it provides different functions to explore the dataset easily. We are using the functions head, tail, info, describe of functions. Head functions is used to display the first few rows of the dataset. By default, it displays the first 5 rows. This helps us quickly understand what type of data is available without viewing the complete dataset. And head of functions, it and df.headof function. Here df represents the data frame and headof displays the starting record. Tail of function works opposite to headof functions. It displays the last few rows of the dataset. This helps us check the ending records of the data. Info function provides a summary of the dataset. It shows the number of rows, column name, data types, and memory usage. It helps to understand whether the data contains numbers, text, or missing values. And describe of functions gives statistical information about numerical data. It provides values like count, mean, standard deviation, minimum, and maximum values. Df.dtype function is used to find the data type of each column in a data frame. It helps us understand what type of data is stored in each column. And df.columns function is used to display the name of all columns available in the data frame. It helps us to understand the structure of the dataset and identify the available features. And last function df.dtype function is used to find the data type of each column in a data frame. It helps us to understand what type of data is stored in each column. For example, a name column may contain string values, age may contain integer values, salary may contain decimal value. Knowing the data type is important because different operations can be performed based on type of data. So, for example, we can calculate the average of numerical columns, but we can't calculate the average of text columns. So, df.column function used to display the name of all columns available in the data frames. Think column function. Selecting column means choosing specific information from the dataset. For example, in a student dataset containing name, age, department and marks, we need only student name and marks. We can select only those columns. This helps us focus on the record information and reduces unnecessary data processing. Selecting rows. Rows represent individual records in a data frame. Selecting rows allows us to access specific records from the dataset. For example, from a customer dataset, we can select the details of a particular customer. LOC function is used for label-based selection. It selects data using row and column labels. It is useful when we know the name or label of the data we want to access. For example, if a dataset has student name as label, we can use LOC to retrieve a specific student details. ILOC function is used for position-based selection. It selects data based on numerical position of rows and columns. For example, we can select the first row or the first few columns based on their position data. Filtering data is used to extract the data based on specific condition. It helps us to find only the records that satisfy a particular requirement. For example, if a student mark data set, we can filter students who scored more than 80 marks. In a sales data set, we can filter products with sales above a certain value. So Pandas allows filtering using multiple conditions. This helps us to perform the detailed analysis on datasets. After creating and exploring a data frame, we often need to modify its structure by renaming columns, adding or removing data, or changing the index. Pandas provides several built-in functions that can make the modification simple and efficient. df.rename of function. This function is used to rename one or more column names. It improves readability without changing the actual data. For example, rename the column age to student age. Use the rename of function whenever column names need to be more meaningful or standardized. df.setIndex of column function sets a selected column as a data frame index and useful when a column contains unique identifiers such as student ID or employee ID. Makes data retrieval easier. So the selected column becomes the row label instead of the default numeric index. df.reset_index of function. It restores the default integer index. The previous index becomes a normal column commonly used after filtering or grouping operations. So this reset underscore index of functions you can be used whenever you want to return the default row numbering. df.drop of column functions remove one or more columns from the data frame, helpful for eliminating unnecessary or unwanted features. So dropping columns reduce the dataset size and removes irrelevant information. df.drop of functions. It will delete the specific row based on their index, useful for removing incorrect or duplicate records. So this function removes only the selected rows while keeping the remaining data intact. df.insert of location comma column comma values. It inserts a new column at a specified position. The LOC parameter determines where the new column appears. Maintain the desired column order also. So, unlike assigning a new column, insert a function lets you control its exact position. df.assign of functions add a new column to the data frame values can be constant or calculated from existing columns and returns an updated data frames. df.replace of functions replace the existing values with the new one throughout the data frame. Useful for correcting data or handling inconsistent values. Can replace numbers, text or missing values. Pandas functions for handling missing values and sorting and ordering. While working with real-world datasets, missing values are very common. Missing values may occur due to incomplete data entry, system errors, or unavailable information. So, pandas provide functions to identify and handle these missing values. IsNullOf function is used to check whether data values are missing. DropNaOf function removes rows or columns that contain missing values. FillNaOf function replaces missing values with a specific value such as 0 or an average value. For example, in a student data set, if a mark value is missing, we can replace it with a suitable value before analysis. So, handling missing values improves data quality and helps in getting accurate analysis result. Sorting and ordering are used to arrange data in a meaningful way. Pandas allows us to sort data based on row or columns. We can arrange data in ascending order or descending order. For example, in student dataset, we can sort marks from highest to lowest to identify the top performing students. Similarly, in sales dataset, we can arrange the product based on sales value to find the best selling product. So sorting is an important data preparation step that helps organize data in a meaningful order. Df.sort values of column sorts the data frame based on the values of a single column. By default, the sorting is in ascending order. To sort in descending order, use ascending equal to false. So sort of values can be used when you want to arrange record based on particular columns such as sorting students by mark or employees by salary. Df.sort values of column 1, column 2, comma ascending equal to true, comma false. This sorts the data frame using multiple columns. The ascending parameters allow different sorting orders for each column. For example, column 1 is sorted in ascending order, column 2 is sorted in descending order. So this method is useful when one column contains duplicate values and need to a secondary column to determine the final order. And df.sort underscore index of function sort the data frame based on its row index. Useful for operations like filtering, concatenations, or merging that may change the row order. By default, the index is sorted in ascending order. So use sort underscore index to resort a logical order based on row labels or index value instead of column values. Next pandas function is aggregation and grouping. Is used to summarize the large datasets and extract useful informations. Pandas provide different functions to perform calculations on data. Sum of function is used to calculate the total value of an data. Mean of function calculates the average value of data. Count of function is used to count the number of available values in a dataset. The max of function find the highest value in the dataset. Min of function find the lowest value in the dataset. Group by functions is used to divide the data into groups based on specific categories. Next panda function is pivoting and reshaping. Pivoting and reshaping are used to change the structure and format of data to make analysis easier. Pandas provide functions to rearrange data without changing the original information. Pivoter function is used to transform rows into columns and create a new table format. It helps to summarize data and view relationship between different categories. For example, sales data can be rearranged to show product-wise sales for each month. Pivot underscore table of functions is used to create summary tables without calculation like sum, average, or count. Melta function converts wide format data into long format structure. It is used when we want to combine multiple columns into rows for better analysis. Stack of function converts column into rows by creating a hierarchical index. Helps in organization data for analysis. Unstack of function performs the opposite operation of stack. It converts row level back into columns. Next panda function is exporting data. After completing data analysis, we may need to save the processed data for future use. Pandas provide functions to export data frame into different file formats. To CSV of function is used to save a data frame as a CSV file. CSV is a commonly used format for storing tabular data. To Excel function is used to export data into an Excel file, useful because many organizations use Excel for reports and documentation. To JSON function converts a data frame into JSON format commonly used for data exchange between applications and web servers. To underscore SQL function is used to store data frame data into SQL database. Data acquisition. Now we can see how to acquire data using a web API. A web API allows us to collect data from an online service in a structured format. In real-time application, APIs are commonly used to get live information such as weather details, stock price, currency, exchange rate, and social media data. In this example, we use Python to send a request to an API and collect the record information. In seeing the example, first we have to import the libraries. The request library is used to send requests and communicate with the API. Pandas is used to convert the received data into a data frame format for analysis. Sending API request. The request is sent to the API URL to fetch the record data. The API process our request and return the data usually in JSON format. And receiving JSON data, the received response contain data in JSON format. It is commonly used because it is easy for application to exchange informations. Finally, I have to convert the data into data frame, so it converts the JSON response into a data frame. This organizes the data into rows and columns, make it easier to analyze. For data acquisition, reading data from open datasets. So the open datasets are publicly available datasets that anyone can use for learning, research, and analysis. These datasets are available from sources like Kaggle, UC, Machine Learning Repository, and government data portals. Panda provides function to read these datasets easily. First, importing the pandas. So we import the pandas library because it provides functions to read and process datasets. Then reading the CSV dataset, the read underscore CSV function is used to load a CSV file into a data frame. And CSV files store data in rows and columns similar to an Excel sheet. Next, creating a data frame. After reading the file, pandas convert the dataset into a data frame. Now we can perform operations like filtering, sorting, and statistical analysis. And last is web scraping from pandas. Web scraping is a technique used to collect data from websites. The third method for data acquisition. When a website does not provide an API, web scraping helps extract record information directly from web pages. The collected information can then be analyzed using pandas. First step is we import the record libraries. Pandas is used for data handling and libraries like Beautiful Soap are used to extract information from HTML web pages. Second is reading the website data. The web page content is collected using a request command. The HTML structure of a web page is then analyzed to identify the record information. Next is extracting the data. The record elements such as table, text, or links are extracted from the web page. Then create a data frame. The extracted data is converted to Pandas data frame. Now the data can be analyzed like any other data sets. Thank you.